Hello and welcome. So this is an example of tree diagram. So here the tree diagram shows all the possibilities at each stage of your process, and it shows probabilities. Last example we did, we were looking at tree diagram that shows frequencies. I like the one that shows probabilities a lot better. I think it's easier to work with. So here we have a standard deck with 52 cards. 12 are face cards and 40 are not face cards. You draw 2 cards without replacement, so you don't put the card back in after you pick it. And the tree diagram is labeled with all the possible probabilities. So on the first draw, you either get a face card or not a face card. So out of the 52 cards in your hand, there's 12 out of 52 that are face cards, so that's the probability of picking a face card. There are 40 out of 52 non-face cards, so that gives the probability of picking a face, not a face card, right? Now, I'm not going to replace the card that I pick, okay? So if we follow this branch, where you picked a face card for your first card, you could pick a face card again, or not a face card. But now, if you picked a face card, there will only be 11 face cards left and 51 cards in the deck because you removed one of the face cards. So the probability of picking a second face card is 11 out of 51, right? If you go this way and you pick not a face card, you removed a face card on the first draw, so there are still 40 non-face cards and 51 cards in the deck. All right. And if I follow this branch and you pick a non-face card first, one option is that you pick a face card for the second one, and that's 12 out of 51. Another option that you pick another non-face card, but because you removed a non-face card and didn't replace it, you have 39 out of 51 non-face cards. Right? And then you basically multiply these probabilities along each branch to give you the probability of these two events happening. 2 face cards, first face, second non-face, first non-face, a second face, and so on. Okay. So we're gonna use that table to find probabilities. So probability of Fn or NF. Alright, so this means that or means add, right? So and means multiply. When you're talking about probabilities, we're gonna see those formulas before. So this is the Fn probability and this is the NF probability. So we're just going to add the 2 probabilities at the bottom. Okay, so we get 480 plus 480 divided by 2652, and it gives me 80 over 221 over, in decimal form, 0.362. Alright, let's find the probability of picking a non-face card given that I picked a face card. So we could use the formula. So probability of N and F divided by the probability of F. So probability of N and F is just NF, right? As put in our truth table, the tree diagram. So NF is 480 divided by 2652. Probability of picking a face card actually, I know that they're the same, but just to be picky, this is going to be Fn because we're going down this branch. So we're told that we know the first card is a face card. So and then we want the second one to be a non-face card, so we need to follow that branch. But it's the same number, so it doesn't really matter. And the probability of picking a face card is 12 out of 52. All right? So we're going to divide. So 480 divided by 2652 divided by 12 divided by 52. We get 40 over 51, which is 0.7843. Right? Now, if you look at this 40 over 51, you might notice that it's this. Right? That's not a coincidence. Right? So you can think of this conditional probability in a different way. Okay, so this says that you are told that your first face card is you're told that the first card you pick is a face card. So basically, this probability right here, it's not 12 over 52 anymore, it's 1, because you know that that event happened. Okay, there's no choice between it could be a face card or not. You're told that that event happened, so that's a probability of 1. So then, given that the probability that it's not a face card is going to be 40 out of 51. So when you multiply these probabilities, 1 times 40 out of 51 gives you 40 out of 51. Okay? So if you're comfortable with sort of reasoning through, that's great. If not, you can just use the formula. Alright, so let's look at C. Find the probability of at most 1 face card. Okay? So, probability of at most 1 face card. This means that I could get no face cards at all, so NN, or I could get the face card first and the non-face card second, or I could get the face, non-face and then face. So this is all the options that include at most 1 face card. So it's not going to include FF because that's 2 face cards. So we can add these up. So we have 1560 plus 480 plus 480 divided by 2652. Let me do that. Alright, so 210 over 221, right? Which is the same as 0.9502. Alright, let's look at Z. Probability of at least 1 face card. Alright, so at least 1 face card means I can have 0 face cards, so FN, NF, and FF. Alright, so this is going to be 480 plus 480 plus 132 divided by 2652. This simplifies to 7 over 17, which is 0.4118. Alright. I want to just mention one more thing with these. So often, when you find the probability of at most or at least, you can do it using the complement. Okay? So the probability of have at most 1 face card is basically 1 minus the probability that you're going to have no face cards. Alright, so if I do 1 minus the probability of NN, oh no, sorry, it's the other way. 1 minus the probability of getting 2 face cards. So that would be 1 minus the probability FF. So this is 1 minus 132 over 2652. And if I do that, 2652 minus 132, we get divided by 2652, we get the same thing here. Right? For this one, the probability of getting at least one face card, this is 1 minus the probability of getting no face cards. So this is 1 minus 1560 divided by 2652. So 2652 minus 1560 divided by 2652. This is 7 over 17, which is the same as we got here. Right? So sometimes it's better to work with the complements because it cuts down on the number of calculations.